Hello, everybody. I'm so excited to kick off the talk programming here on the main stage, and I'm really happy to introduce Chloe McAree. So, a little bit about Chloe. Chloe is a senior software engineer at Hamilton Robson. She has experience working on small research prototypes using cutting edge technologies, right through to building large scale web applications using multiple technology stacks. Chloe is an active member of the global tech community. She has been an AWS community builder for the past 3 years and is also a former Belfast City lead for Women Who Code. Chloe uses these outlets to share her learnings and experiences through blogs and other events. So I'm so excited to welcome Chloe.
Hi, everyone. Great to be here with you all today and starting off the conference. I hope everyone's been having a great day so far. Just let me know if you can't see my slides, but as Anna said, I'm Chloe McAree. I am currently an AWS community builder and I am a senior software engineer at Hamilton Robson. So I have been with Hamilton Robson for about 18 months now, and we are a technology company that deliver digital services across social media, finance, visitor attractions, and enterprise. And today I'm here to talk to you about securely accessing private files within your client applications. So let's go ahead and dive straight in. When you're building media-rich applications that handle assets like images, audio, or video, some of these assets may be publicly available, while some might be stored privately and only accessible by certain users. If you're familiar with AWS, you may have come across S3. If not, don't worry, it is Amazon's simple storage service for object storage, which offers data availability, security, and performance at scale. In S3, files are referred to as objects, and by default, all objects are private. So this just means that the owner of the object has permissions to access it. To work with AWS services like S3, it is common to use the AWS SDK, which is the software development kit, and it's available in many popular languages. Using the AWS SDK within backend services is a secure and effective approach to programmatically interact with AWS services, as you can authenticate with the SDK using your AWS client ID and secret to access the required service functionalities. So here is just a screenshot of some of the functionality in the SDK that's specific for S3. You can see that it allows you to do things like get files and upload files, and this is perfect for the backend. However, when it comes to client-side applications like web applications or native mobile apps, this option is not recommended, as these applications are typically bundled and made publicly available. Since they are public, it allows people to access and inspect the code or the app bundle, exposing our secret AWS credentials and potentially posing a security risk. Unauthorized access to these credentials could potentially allow someone to gain access to all of our AWS infrastructure. You might be thinking, why don't we just send a request from the client into the server, and then in our server just download that file from S3 using the SDK, and then just send that file directly back to the client like we're doing in this example on the screen. Now, this approach is okay for small files, but with larger files, cost and performance does not scale well. It could lead to excessive data transfers, performance issues, and just multiple long-lasting connections to the server. Secondly, you'd be serving your images directly from the server, so you're utilizing valuable compute resources. And if you were to offload this to your data source, which in this example would be S3 instead, you could optimize your server's performance and resource allocation. Additionally, if you were using API Gateway, which is AWS's API management tool that sits between your client and a collection of backend services like we're using on this example in the screen, it imposes a 30-second timeout restriction, and this just might not be enough time for you to be able to complete that file transfer. To avoid these issues, we need to find a way to allow our client apps to go directly to S3 for files, but we need to consider how can we authenticate these requests. This is where pre-signed URLs and pre-signed cookies come into play. AWS pre-signed URLs and pre-signed cookies are authentication mechanisms that allow you to grant temporary access to your content to a limited number of users without exposing your AWS credentials. So let's start with URLs. Pre-signed URLs allow you to grant temporary access to S3 objects, so to users who don't have permissions to directly run AWS operations in your account. This allows users or clients with the pre-signed URL to access the objects directly in S3 without requiring their own AWS credentials. Let's explore how this works in practice with a real-world example. So within one of the applications I am currently working on at Hamilton Robson, we need to store user passport images and allow the user to view them. So users should be able to navigate to their profile and view their passport either within the mobile app or the web app. Let's walk through the flow, starting with the client, which in this case is a mobile app, but it would be the exact same flow for any web apps as well. So firstly, the user navigates to their profile page and they click the View Passport button. This would then trigger the client to send a request to API Gateway, which again is a service that just sits between our client and backend services. Here, I would have a custom authorizer set up to verify the user. So maybe do some checks like checking the user's bearer token, see if they're logged in and see if they have a valid user session. If the user is authorized, they proceed to the backend service. And this backend service could really be implemented with a variety of AWS services. You might want to use a Lambda here or an EC2 instance, just whatever works for you. Here we would have the database to look up the file name and file path for the user's passport image. And then it is here within this backend server that we can authenticate with the AWS SDK using our secret credentials. And this would allow us to use the SDK's functions to generate a pre-signed URL that is specific to this user, the desired file, and it can have an associated expiry time. Once the pre-signed URL is generated, we send it back to the client. The client can then use this authenticated URL to directly access the passport stored in S3 without requiring any further authentication until that URL expires. So this way, the user can securely access their passport image from S3 directly without us exposing any AWS credentials or granting long-time access permissions. This flow can be used not only for fetching files, but it can actually be used for uploading files securely to S3 as well. So in the code snippet above, I am using the SDK's getSignedURL function, and you can just see that I am passing in the S3 bucket name, the file path of the resource that we want to access, and also the expiry time. So when using pre-signed URLs, S3 will check the expiration date and time of the signed URL at the time the HTTP request is made. The main benefit of pre-signed URLs is their ability to enhance security by limiting access to authorized users and reducing the need for additional authentication mechanisms. They also provide more fine-grained control over your S3 objects access. However, pre-signed URLs do have some limitations, and one of the main limitations is that they can only be used to grant access to or to upload a single file. So in other words, one URL would always be equivalent to one file. Now let's take a look at pre-signed cookies. So pre-signed cookies are also a way to grant temporary access to S3 objects. They are signed with AWS security credentials and are stored in a cookie that is passed along with a HTTP request to access protected content. To generate pre-signed cookies, you need to set up a few things that you don't necessarily need to set up when you're working with pre-signed URLs. So firstly, you must create a CloudFront distribution. Then you would need to generate a private and public key pair, where the public key would be uploaded to CloudFront and associated with a distribution. To better understand how this whole process works, let's walk through it again with a real-world example. So in Hamilton Robson, we have built a number of applications for large visitor attractions, all of which use the same underlying API. Within our visitor attraction apps, there is some free content that is publicly accessible, but there's also paid content that can only be accessed by ticket holders. So in my example, you can see we've got the women who code to our app today. Firstly, the user within the client application would request to verify their ticket. This triggers the app to send a request to our backend server. So similar to the previous flow, we utilize API Gateway, which would be equipped with a custom authorizer to just verify that ticket. After verifying the ticket and identifying what attraction it is for, we would then leverage the AWS SDK again to generate a pre-signed cookie to all of the resources that we store for that attraction using our private key. The details of how this process works will be explained in a few slides' time, so don't worry. Once a pre-signed cookie is generated, it is sent back to the client. The client can then use this cookie to download all resources related to this attraction. These resources may include artwork, maybe audio files for the attraction's audio guide, and various videos. When the client makes the request using a cookie, CloudFront validates the signature of the cookie using the associated public key and checks the request policy before granting access to the requested files. The cookie generated also does have a specified time limit, indicating how long it remains valid before that user would have to re-authenticate again. So the code snippet here shows how we generated the pre-signed cookie using the SDK. Previously, I mentioned that when you're using pre-signed cookies, you need to have a public and private key. Whenever you're configuring CloudFront, you would provide your public key and you would receive a key per ID. And at the top of this code snippet, you can see that I pass in that key per ID and I pass it in along with our private key in order to create a signer. Next, we start to set up our function options. In the example, you can see that the URL field used is the CloudFront base URL, and here we can then specify the path to the resource that we want to generate a cookie for. It is worth noting that wildcards can be used here to provide access to entire directories, so this means that you don't have to generate individual cookies for each resource. Additionally, we pass in a Unix timestamp to indicate the cookie's expiration time, and once the cookie expires, the user would then need to re-authenticate to gain access again. So some of the benefits of pre-signed cookies include their longer lifetimes compared to pre-signed URLs. Another significant advantage is that pre-signed cookies can be used for multiple S3 objects, offering a more efficient and streamlined approach. However, it is important to note that pre-signed cookies do have certain limitations, and one of the main ones being that they are more complex to set up, as they do require that generation of public and private keys and also the configuration of CloudFront distributions. So what is the difference between pre-signed URLs and pre-signed cookies, and which one should you use? Overall, both of them provide the same basic functionality of just really allowing you to control who can access your content. The choice between them does depend purely on the specific use case and requirements of your own applications. So pre-signed URLs are preferable when you need to share private content with a limited number of users and when you want to grant temporary access to content to users without AWS credentials. On the other hand, pre-signed cookies are more suitable when you need to grant temporary access to multiple S3 objects. It's worth mentioning that signed URLs take precedence over signed cookies, so if both a signed URL and a signed cookie is used to request the same file, the authentication would be based purely on the URL. So to enhance the security and effectiveness of pre-signed URLs and cookies, here's just some recommended best practices. Firstly, set a short expiration time to minimize the risk of unauthorized access and to really just enforce re-authentication if needed. Always use HTTPS to transmit pre-signed URLs and cookies to ensure the encryption of data and prevent interception and tampering. And lastly, generate pre-signed URLs and cookies only for authorized users to just help mitigate risk of unauthorized access. Following the best practices can help ensure security and integrity of your application. Overall, AWS pre-signed URLs and pre-signed cookies are powerful tools that can improve the security and performance of your web applications. While this presentation focused on using them purely for fetching and uploading resources, it is important to note that this mechanism can also be utilized for content hosting, for restricting web page access. But delving into all of the web hosting aspects would be a completely separate talk, and that is all I have time for today. But thank you all so much for listening, and I really hope you find this interesting and have learned something new. I do have a blog version of this talk. If you're interested in reading more, just scan the QR code to access it. I have my Twitter and LinkedIn usernames here if you want to connect, and that last username is my Medium account. So if you're interested in cloud, I do write some blogs on some of the stuff I'm working on, like side projects, study notes for certifications, and just general tips and advice. And if anyone has any questions, I'm happy to take them now. I don't know if I have enough time or if I've went over time, but I'm also happy to take them over Twitter or LinkedIn, just whatever suits.
Thank you so much, Chloe. We have about 2 minutes for questions. So I'm going to start off a little bit. I guess my first question for you as we start thinking and have the questions coming in, that's a little bit less about your presentation. But as you saw at the beginning, this is like a very international group. And I'm wondering, and it also means that different countries have different like security requirements and also data requirements. And that's something that we think a lot about at Women Who Code when we're building our own. So I'm wondering, in your current position, like who sets that expectation and how do you work with those people and how does that affect your work?
Yeah, definitely. Great question. And I think a lot of times when we're thinking about data security, we are thinking about the user personal PII data that we're collecting within a system. And I feel like that would be the default to go to. And what I was trying to convey in this presentation today is that we also need to be protective of our own secret credentials when we're developing. So it's not just the data that we're consuming, which of course we need to make sure we're protecting at all costs, but it's also when you're developing, you need to think about those kind of strong principles. You're going to be using different API keys. You might have secret tokens. There's a lot of things that you're generating to use external services. So you really got to think about who can access them. Are they definitely secure in your server? You're not exposing them publicly anywhere. And even in terms of sharing them between your dev team, are you storing them in encrypted form? Can anyone access them? Are they being rotated regularly? And for us, that's something at Hamilton Robson we would decide as a team. We would get together, we would make a bit of a development manifesto of how could we come up with the best practice to be able to understand how those keys are moving and how we're storing them.
I'm gonna we'll finish this up. I'm gonna post shout out some of the amazing feedback that you're getting. Like Yasmin says, informative. I think people doesn't seem like they've worked with pre-signed URLs and cookies in the past. And Sasha's saying that Sasha's currently focused on working on authentication at work, and it's great to hear about others talking about it. So thank you so much, Chloe. Is there anything you want to make sure people take away at the end? I think you talked a little bit about how you talk a little bit about certifications or anything like that. So if you can just say a little bit more about those certifications and how it connects to this project, that would be, let's close it out with that.
Yes, definitely. Well, I'm glad people are enjoying it, and I really hope you have taken something interesting from the talk. As I mentioned at the start, I am an AWS community builder. It is an absolute great community of fellow people working within AWS. You're always sharing new content that they come across. So I would encourage anyone to look into that community to see all of the amazing blogs and resources they have. I think the next application round for it is coming up in July or August time. And there also is the Women Who Code Cloud community and the Cloud Slack, which is incredible for people sharing resources and learning as well. I have done a few of my AWS certifications and I would recommend them. I find for me, doing certifications helps to just build my technical confidence and just allows me to feel like I know what I'm talking about. Even though sometimes you're working with it and you do know it, it just gives me just that little bit of extra confidence. So yes, as I said, on my Medium, I have study notes, advice and tips and stuff on there as well. So if you do want any more information, feel free to reach out to me. I'm happy to share on any links to help anyone get more involved in the cloud community in general. But thank you all so much for listening.
Thank you. Thank you, everybody. We're going to take about a 30-second pause, and I'll be right back with our next speaker. Thank you so much, Chloe.